Champion Science Ventures program is an inquiry-based program. What does that mean? When we say inquiry-based, we actually mean we want the children to take some of the learning themselves. They're going to ask and answer their own questions through some of the hands-on projects they're doing. To take a look at what this actually means in the context of a lesson, we're going to do a lesson, we're going to do the right stuff. It's actually a lesson that explores the experiments and the science that the Wright brothers had to go through when they designed the Wright Flyer, the world's very first working airplane. They were fantastic experimenters, and the children are going to do experiments just like they did to understand and master the four forces of flight, and it's a great way to explain to you guys what we mean when we say inquiry-based science. In the lesson The Right Stuff, children build, before they build their Wright Flyer, they actually build a balsa glider. They do this in groups, and by building this glider and taking it outside, they're going to use it in different ways to explore the four forces of flight. The four forces of flight are lift, provided by the wings, the weight of the aircraft, or gravity, pulling you down, thrust, provides the forward motion, and drag is what is holding the airplane back. So children explore lift, thrust, drag, and weight by building a glider and experimenting with it to find out how each of those forces affect the plane. Anything that flies is made out of things that are light. In this case, the plane is actually made out of balsa wood. It comes in a kit. Children need to be careful putting together balsa wood. By the very nature, it is light and flimsy because it needs not to have much weight. So they need to be careful when they put it together so they don't break things as they're pushing it in. However, if any of the balsa parts do break, you can use amazing balsa weld or clear tape just to go ahead and bring everything back to working condition. First thing the children are going to do is build a very simple plane. Looks a lot like that. They're going to take it outside. You're going to go over flight rules with them so they fly in a controlled manner so they're not stepping on each other's projects, things like that. And we're just going to do a test flight. They're going to take the hand they write with and they're just going to throw it once and measure where it lands. You can use little tape flags if you want to bring some math into the lesson. You can actually have them measure and write down the results using a tape measure. But we want to just get a baseline for what our plane does. Next, you're going to explore with the children. What would happen if we increase the weight? Whenever you're doing inquiry-based science, you want to ask divergent questions, questions that can have multiple answers. A diversion question, what happens if we made the plane heavier? And you have the children guess and discuss amongst themselves what they think would happen, and then provide you with an answer. Key teaching thing, a lot of times when teachers ask questions, they ask questions, but they don't give enough time for an answer. A lot of times in schools, we're always in a rush to get things done. In this inquiry-based lesson, it's more important that the children have time to form their own ideas and then test and see if they're right or not to build those connections than it is to rush through A, B, C, or D. So make sure you pause, count maybe quietly in your head. Give the children time, 30 seconds, a minute, to actually answer the question and form their own ideas that they then can test against before we're rushing to provide them with the answer. Science, the activity, should be providing the answer. So for the weight question, real easy. The children are just going to take some pennies and they're going to weight their plane. They just simply tape them to the wings. Then again, they're going to go ahead and throw, and they're going to see what weight does to the plane. Write down the results. Does it go further? Does it go less far? After that, we can explore lift. We can go ahead and take out the big wing, and this kit actually comes with a small wing. Then go ahead and put the small wing in. Fly it. How does that affect it? Make sure they're forming their hypothesis. You're actually getting from them the ideas they have before you do it. So we've done weight, we've done lift. Next up would be drag. So you go back to the original wing. And for drag, you're just going to use a piece of paper. Tape a piece of paper to the back of the plane, fly it. How does that increases the drag? How will that affect the flight? So we've done weight, drag. Finally, we'll get to thrust. You can have the children try and throw at different strengths, but it's hard to measure that. You don't have constants, and in science we're always looking to only change one thing and have it be predictable so you can make an informed critical thinking conclusion. So what we're going to do, or how I suggest you do it with the kids, and it's in the lesson, is you throw it with your dominant hand, you throw it with your non-dominant hand, and measure how far the plane flies. So a great example of how we try and include divergent, open-ended, inquiry-based questioning in the lessons. Most of the lessons have some form of question answer. They're highlighted in the lesson plan, where you're to pause and let the children form their own ideas and then test those ideas. When you think a certain way about something and then find out you're right or wrong, it cements the learning. It really brings in the making connections in your brain and increases retention of the science concepts. Inquiry is a key part of how these lessons should be taught. Leave time for it, practice it, use inquiry-based questioning, and really help the children develop their critical thinking skills.